This is question 21 to question number 30 of 2017 WAEC maths question. You're welcome to my page. This is Oasis Online Math. And today, we are solving these questions one after the other. We are given that cos 30 is equal to sin 60. Of course, they are equal. Is equal to root 3 over 2. And sin 30 is equal to cos 60, which is 1 over 2. We are now asked to evaluate tan 60 minus 1 over 1 minus tan 30. We should remember that tan A is the same thing as sin A over cos A. That's the identity for tan A. So therefore, tan 60 will be equivalent to sin 60 over cos 60. And we have been given that sin 60 is 3 over 2 and cos 60 is 1 over 2. So which means this will be divided by 1 over 2. That is root 3 over 2 divided by 1 over 2 according to this. So we have root 3 over 2 multiplied by 2 over 1. So by this, you see that this is just ordinary root 3. So it means tan 60 will be minus root 3, then that will be minus 1 here. So also let's check for tan 30. We use the same identity, which says tan 60 is equal to sin 60 over cos 60. But here is tan 30. So it's going to be tan 30 is still going to be the same thing as sin 30. We're going to use the angle given, angle 30. So we're going to use sin 30 over cos 30. And we are given that as sin 30 is 1 over 2 and cos 30 is root 3 over 2. So which means this will now be divided by root 3 over 2. So that is 1 over 2 divided by root 3 over 2, which is 1 over 2 multiplied by 2 root 3. So here we shall have ordinary 1 over root 3. So this we have tan 60. Tan 60 was root 3. So which means root 3 tan 60 minus 1 will now be root 3 minus 1 all over 1 minus tan 30, which is now 1 minus tan 30 is 1 over root 3. So that is 1 over root 3. You must ensure we simplify it to have our good and well simplified answer. So numerator here, root 3 minus 1 all over root 3 minus 1 over root 3. Of course, if you make this to be over 1, the LCM is root 3. And root 3 in root 3, 1 times root 3. So that's how we have this. So it's now be equal to, it means all this is now being divided by this. So which means root 3 minus 1 divided by root 3 minus 1 over root 3. So to simplify this further, we have root 3 minus 1. Hence, this turns to multiplication, and the reciprocal of this will be written, which is root 3 over root 3 minus 1. So from the look, we see that this cancel this. We're having only root 3 left. Hence, our evaluation will be root 3. So the correct answer here is option C. Here is question 22. The question says that the average age of a group of 25 girls is 10 years. 25 girls is 10 years. If one girl aged 12 years and 4 months join the group, find the new average age of the group. First and foremost, we need to know that average is equal to sum of number. We are dealing with numbers now. Of course, the ages are represented by numbers. So sum of ages or numbers, sum of ages on the number of ages. We are using ages now. So therefore, we are told that the average age of 25 girls, so which means we are dealing with 25 ages. We are told that the average is 10. So which means 10 will be equal to, we don't know the sum. Let's represent that sum as Sn, and the number of the girls is now 25. So 25. So if we cross multiply, it means the sum of these 25 girls will be 10 times 25, which is 250. So the sum of their ages is 250. Noted. And we are now told that if one girl aged 12 years and 4 months, 12 years and 4 months join the groups, if that girl joined the group, it means the number of the ages will be increased by 1. That is, total number of these people we are calculating their ages. That will give us 26. We now have to find the new average age of the group. So the average age of the group, new average now. The new average now will now be, don't forget, this number of the ages will be 26 rather, plus 1. Then sum of their ages will be increased by 12 years, 4 months. So that will be 250 plus 12 years, 4 months. 12 years, 4 months will be, that'll be 4 months will be 12 over 4. Okay, everything over 25 plus 1, that is 26. So here we shall have 250 plus 12 points, that'll be 12.33333. Okay, all over 26. If we check that on our calculator, we are going to have 10.09 thereabouts, which is approximately 10.1 years. And if you check that, we'll see that option A satisfies the question, which is the correct answer. This is question 23. We are given that in what number base was the addition 1 plus nn is equal to 100 for n greater than 0? Can be done. Okay, please let us know that nn here doesn't naturally mean n times n, and we know that n times n is n squared. No, that's not what the question means. So for n greater than 0, okay, then let's start from this. This is where the major problem lies. So we say that our n, let's assume that this number is in the base, let's say base b. It's in the base b. So if we extend it with respect to its base, that is, we can say by expressing this, let's say this is base b. We want to express it in base 10. So we are going to expand it by saying n times b plus another n times b, then raised to the power of 0, then 1. So naturally what we have here can be n times b, that is nb, plus b raised to the power 0 is 1. So we have ordinary n here. So nn base b is expressed as b nb plus n. So that's the first step. Then the second step is to consider is 1 is of any base. This one here is of any base. Okay, so even if we express it as base b, that is 1 of base b, it always end up as 1 times b exponential 0, which is still end up being 1. Okay, so definitely for our left hand side, which is 100, our left hand side, which is 1 plus nn, compared to this, let's see what we have. So hence we have our left hand side, which is now 1 plus nn. Don't forget our nn is now becoming this, so it can be 1 plus nb plus another n. Likewise, if we express 100 as base b, okay, if we express 100 as base b, we are still going to, so we have 1 times b plus 0 times b plus 0 times b, then we raise the power 0, 1 and 2. So hence here we're going to have 1 times b squared, we have b squared plus b times 0, 0, 0. So only this will be b squared. So therefore from our left hand side, which we have been given this, and we have been given this to our right hand side, so definitely they are both equal by equating them. So we have 1 plus nb plus n is equal to b squared. So by bringing them together to form, of course it's forming equation here. So from the look of things here, we see that our b squared can be arranged as 1 plus nb plus n, and we can see that b squared is now equals to 1 plus n is common here, we can factor n, then we have n is equal to b plus 1. Okay, so definitely if we move this one to this side, we are going to have b squared minus 1, which is equal to n into b plus 1. So that's the difference of 2 squared on our left hand side here. So which means b minus 1 into b plus 1, which is now equal to n into b plus 1. So from the look of this, we see that both sides, this can actually cancel out. So definitely our n is going to be equal to b minus 1, which is the same thing as b that we are looking for, the base. Taking 1 minus 1 to this side, becomes n plus 1, which is our correct and simple answer for that. So let's check for the correct option, which is n plus 1, option B. This is question number 24. We are to simplify root 2 into the bracket of root 6 plus 2 root 2 minus 2 root 3. We are going to use root 2, distribute it over this by multiplication. So root 2 times root 6, that gives us root 12, plus root 2 times root 2, of course that will give us root 4, then root 2. That will be 2 root 4 minus 2 root 3. From here, root 4 is 2. That will be 2 times these 2, that will give us 4. And likewise, root 12 is the same thing as 4 root 3. Root 4 times root 3, then minus 2 root 3. So here will be 2 root 3. 2 root 3 plus 4 minus 2 root 3. From here we see that plus 2 root 3, then minus 2 root 3 cancel each other. So what we are leaving here with is ordinary 4, which is our correct answer. Question 25 says the three exterior angles of a polygon are 30, 40, 60. If the remaining exterior angles are 46 each, name the polygon. We are told that the three exterior angles of a polygon are 30, 40, 60. If the remaining exterior angles are 46, we don't know the number of sides that this polygon has. So we must know that sum of exterior angles of a polygon, exterior angle here, this is also an exterior angle here. If we have something like this as well, which form an exterior angle here. So if this is x, y, and z, x plus y and z must give us 360, because their exterior angle of this polygon must give us 360. So we know that 30, 40, 60, and 46 in multiple times, because we are told that the other exterior angle, the remaining exterior angles are 46 each. So we don't know that. So let's say we sum all this together. 30 plus 40, 70, plus 60, that's 130. Okay, so definitely the sum will be 130 plus this 46. This 46, we don't know how many are they. So let's represent them with n, because that's the multiple of this 46, which we don't know. Don't forget, you still sum up to be 360. So which means 46n will be equal to 360 minus 130. So 230. So definitely our n can be 230 divided by 46, which is 5. Our n will be 5. If our n is 5, don't forget we are looking for the number of sides, though this is not the number of sides, though we are given other 3 sides. What? 1, 2, 3. So which means 3, the number of sides will now be 3 plus this 5, which gives us 8, of course. And the name of polygon with 8 sides is octagon. Here is question 26. It says we should simplify the expression a exponential 2 b exponential 4 minus b exponential 2 a exponential 4, all divided by ab into the bracket of a plus b. From the look of things, you see that a square is common, it can be found here, can also be found here. Likewise, b square can be found here, b square can be found here. Let's factorize them out. So a square is common here, likewise b square is common here. So we have a square, then b square, into, we have a square to divide this a, that will be 1, then b square to divide b is power 4, that will be b square minus a square to divide a raised to power 4 here, that will be a square. We have a square, then b square to divide b square, so we have 191 all over ab into the bracket of a plus b. From the look, we see that this a we cancel 1 a here, this b we also cancel 1 b here, so we are left with ab at the numerator. At the numerator here. So, and you can see that this is different of 2 square. And different of 2 square says that b square minus a square, we shall have b minus a into the bracket of b plus a. Everything is still divisible by this, a plus b. From here, we see that this will strike this out. So what we are left with is ab into the bracket of b minus a. When we check our option, we realize that none is the same. So let's expand this. So we have ab square, a times ab times b, that will be ab square minus a square b. So let's check ab square minus a square b. So we see very well, this and this, they look alike, but we have to be very careful. So our correct option is option D. Here is question number 27. It says we should find the sixth term of the sequence 2 over 3, 7 over 15, then 4 over 15. We are not told whether it is AP or GP. Let's test whether they are AP or GP. For AP, if we can test that T2 minus T1, if we can subtract the first term from the second term, and it's giving us the same thing as the subtraction of second term from the third term, then we can conclude that the sequence is AP. And for GP, if we can find the ratio of a term with that of the term immediately preceding it, that is, if we can divide this by this, okay, that is T2 being divided by T1, and it's giving us T3 being divided by T2. If this holds, then such sequence is in geometrical progression. So let's test for AP first. Let's test for T2 minus T1. If it holds, then it is AP. T2, our T2 is 7 over 15 minus T1. Our T1 is 2 over 3. 2 over 3. Here, our SEM is 15. So we have 7 minus 3 in 15, 5. 5 times 2, that's 10. Subtract 10 from 7, that is negative 3 over 15, which is 1 over 5. Minus 1 over 5, rather. So if this is T2 minus T1, checking for T3 minus T2, that is this. T3, our T3 here is 4. That is 4 over 15 minus T2, 7 over 15. Of course, from the look, we see that this will be negative 1 over 5 as well. So therefore, this is an AP. And since this is an AP, what we just observed here is our common difference. This is our common difference. And in an AP, we must know that the nth term of an AP is always the first term plus the number of the term minus 1 multiplied by the common difference, D. So here, our A is the first term, our N is the position of the term, or the number of the term that we are looking for. And our D is common difference, which is minus 1 over 5. So let's substitute in this formula, and let's see what we have. T6 will be A plus, this is 6, N is now 6, that will be 6 minus 1, that is 5, that will be 5D. So this is our T6, that is the sixth term. So using this formula, our A is 2 over 3, that will be 2 upon 3 plus 5 into D. Our D is this, negative 1 over 5. Negative 1 over 5. So if we simplify this, we realize that we have 2 over 3 minus 1 over 1, which we can say as 2 over 3 minus 3 over 3, which will definitely give us minus 1 over 3. That is the sixth term, minus 1 over 3. Option minus 1 over 3 is option A. Question number 28. It says that the roots of a quadratic equation are minus 1 over 2 and 2 over 3. We should find the equation. It's very simple. Let's say the roots of this equation is in terms of x. Okay, let's say the roots are like this: x minus, let's say, alpha is our first root, then x minus beta must be equal to 0. We can use this formula. Of course, we can use another one as well. So our alpha now is minus 1 over 2, and our beta is 2 over 3. So we can say that x minus 1 over 2 will give us plus 1 over 2 into another x plus minus 2 over 3 is equal to 0. So we can write this expression, this factor, as 2 into 2x plus 1 into, then this one as well, we can write it because of this 3. We can say this 3 you multiply this. We can as well say this 2 multiply this. So we have 3x minus 2 all equal to 0. If we open this bracket and simplify, we get our final and correct equation. So let's do that. So 2x times 3x, that gives us 6x squared. Then 2x times minus 2, that gives us minus 4x. 1 times 3x, that gives us plus 3x. Then 1 times minus 2 gives us minus 2 equals 0. So simplifying this, we have 6x squared minus 4x plus 3x, that's minus x, then minus 2. These are correct answer. Or if you like, you can use this formula that says x squared minus sum of the roots that you are given, you find their sum, plus the product of that root. Equate everything to 0. When you find the sum and you find the product, substitute it here, the sum here and the product here. You simplify it, then you get your final answer. So these are final answer. Checking our option, we have option B as our correct answer. Question number 29. We are to make x the subject of the formula or subject of the relation, which says d is equal to square root of 6 over x minus y over 2. So we must first and foremost break these square roots by squaring both sides. So when you square both sides, it shows that the square root will go away. So we have square here, square here. So this we undo this. So we have d square is equal to 6 over x minus y over 2. What we need to do is to make x subject of formula. So this is where x is found. We can decide to take this to this side. So we are going to have d square when minus y over 2 crosses to this side becomes plus. We have plus y over 2 is equal to 6 over x. Okay, now from the look here, we see that we can decide to remove this 6 by multiplying both sides, or multiplying through by 1 over 6. Okay, multiplying through by 1 over 6, because if you multiply this by 1 over 6, this will remove this. We are going to have 1 over x left. We are going to have 1 over x left. Okay, so when you multiply through by 1 over 6, that is 1 over 6 to multiply d square plus another 1 over 6 to multiply 1 over 6 to multiply y over 2 is equal to then 1 over 6 to multiply x over 6 over x. So we can see that this will undo this. So here we have d square over 6 plus y over 12 is equal to 1 over x. So if we simplify the left hand side, we see that our LCM here is 12. So 6 in 12, that's 2. 2 times d square, we have 2d square plus 12 in 12, that's 1. 1 times y, that is y is equal to 1 over x. If our x is 1, if our 1 over x is equal to 2d square plus y over 12, we are looking for x, not 1 over x. So this is reciprocal of x. So find the inverse of this, that is, turn this upside down and also turn this upside down. So both sides will be affected. So therefore our x will be 12 over 2d square plus y. These are final and correct answer. Option D. That is 12 over 2d square plus y. This is question 30. We are to consider the two statements P and Q. We are told that statement P says it is hot. Statement Q says it is raining. Which of the following symbols correctly represent the statement it is raining if and only if it is cold? It is raining if and only if it is cold. Okay, it is raining. It is raining means Q. Statement Q. It is raining means Q. So let's even jot it from here. Q. Okay. it is raining. If and only if, and mean conditional statement. Conditional statement, that means this, if and only if it is cold. But here, we are not told that it is cold, which means negation of ought is cold. That is negation P. It is raining if and only if it is cold. So the correct statement here that represents this is going to be going to be Q, if and only if, not P. Let's check the options there. This can be found, of course, Q. This is our correct and final answer. If you find this useful, please ensure you follow my channel. Turn up your bell notification so that it's going to notify you whenever we upload a new content like this. Thank you very much. Bye for now.